Organic chemistry is the study of carbon compounds. There are many millions of organic compounds that you can make using hydrogen and carbon and arranging them in different ways. However, the study of organic chemistry includes any molecule with a carbon backbone.
This is an introduction to functional groups of organic compounds. Functional groups are responsible for the characteristic chemical behavior of compounds. Here's an example of a molecule that contains different functional groups as shown here.
There are many different functional groups. You may have heard of the alcohol group. This is a hydroxyl group and is a hydrogen bonded to an oxygen, which is then covalently bonded to the rest of the molecule. This group can be attached to any of the alkanes to form alcohols, their name all ending in -ol. For example, methanol, ethanol, and propanol. The alcohol functional group means that all these compounds will react in a similar way and will have similar properties. There are lots more functional groups. Esters, which give molecules a sweet smell and make them useful for perfumes and flavourings. Ketones, which make molecules useful as solvents. Amines, which can be used as dyes and useful in making medicines. Some molecules have more than one functional group and give molecules different properties still.
Carbonyl-containing functional groups are functional groups that contain a carbonyl group. A carbonyl consists of an oxygen doubly bonded to a carbon, which is then bonded to additional groups. Here are 5 different carbonyl-containing functional groups, and here are the carbonyl groups within the 5 functional groups. We'll first take a look at aldehydes and ketones. Aldehydes. Aldehydes consist of a carbonyl group which is bonded to a hydrogen and a carbon or hydrogen. Some examples of aldehydes include formaldehyde, which is the simplest of all aldehydes and features a central carbonyl bonded to 2 hydrogen atoms. If one of these hydrogens is replaced with a methyl group, then acetaldehyde results. Benzaldehyde is also an aldehyde, as its name would suggest, and features a carbonyl group attached to an aromatic ring. Ketones are similar to aldehydes in that they have a central carbonyl group, but ketones differ in that the carbonyl carbon is bonded to 2 carbons. Like thiols or ethers, ketones can be symmetrical or unsymmetrical, depending on which carbon groups are attached to the carbonyl carbon. Acetone is an example of a symmetrical ketone and features 2 methyl groups attached to the carbonyl carbon atom. Acetophenone is an example of an unsymmetrical ketone and features an aromatic ring and a methyl group as its 2 carbon groups attached to the central carbonyl. Cyclohexanone is an example of a symmetrical ketone that features a ring as both carbon-carbon groups attached to the central carbonyl group. Ethers. Ethers feature a central oxygen bonded to 2 carbon-containing groups. If the 2 carbon groups attached to the central oxygen are identical, then a symmetrical ether results. Diethyl ether is an example of a symmetrical ether. It features 2 ethyl groups attached to the central oxygen. On the other hand, if 2 carbon groups attached to the central oxygen are different from one another, then an unsymmetrical ether results. Benzyl ethyl ether is an example of an unsymmetrical ether. It features an aromatic benzyl group and an ethyl group attached to the central oxygen. Esters. Esters feature a central carbonyl group that is bonded to an oxygen atom. The oxygen is then bonded to a carbon, and the carbonyl carbon is bonded to either a carbon or a hydrogen. Ethyl acetate is a common ester, which features the carbonyl group attached to an oxygen, which is then bonded to an ethyl group, while the carbonyl carbon is bonded to a methyl group. Methyl benzoate is an example of an aromatic ester, featuring a methyl group as its carbon group and an aromatic ring for its other carbon group.
Now, by the end of this video, you should know that organic chemistry is the study of carbon-based molecules. You should also know that functional groups are groups of atoms which give molecules similar properties.
Carbon. Carbon is at the center of it all. There is no life without carbon.